All right, pre-calc students, I promised videos explaining why the double angle identities work and half angle identities and other ones as well. So I'm going to go through that. Bear with me as writing this out with the mouse is not the easiest thing in the world, but we'll do what we can. So first off, the sine of 2 theta is equal to 2 times the sine of theta cosine of theta. Now, why is that? Well, if I consider sine of 2 theta to be the same as the sine of theta plus theta, then I could use my sum identity for sine. So sum identity for sine would go something like this. I'd take the sine of the first angle, theta, times the cosine of the second angle, which is also theta. And then I would add the cosine of the first angle, theta, times the sine of the second angle, which is still theta. And then I've got sine theta, cosine theta, and sine theta, cosine theta here as well. So if I, consider these to be like terms, which they are, because it's just a product and I'm moving those things around, well, that means that sine of 2 theta is equal to 2 of these sine theta, cosine theta expressions. Okay? That's cosine of theta. So there would be the double angle identity for sine. Now with cosine, there's actually 3 different double angle identities. Now there's a couple other ones for sine as well. You can do some different things, but these 3 tend to show up on a fairly regular basis in the different things that we do with these identities. So to go through each of these, we're going to start by finding this one. It's a little bit easier. And I'm going to change theta to x if you don't mind, because it's going to be easier for me to write x. So hopefully that will make sense. You can write theta, I'm going to write x. If I use the cosine of x plus x, it's the cosine of 2x, okay? With the cosine sum identity, I take the cosine times cosine. So cosine of the first times cosine of the second. And then I have the opposite sign in the middle, so I'm going to subtract, because I was adding here, I'm subtracting these two things. I'm going to subtract the sine of the first times the sine of the second. Okay? Now, if you'll notice what that gives me is it gives me cosine times cosine is cosine squared. So I got cosine squared x, or theta, minus sine squared x, or theta. Okay? And there you have it. So that would be the first one. Okay? Cosine squared theta minus sine squared theta. Now, if I wanted to find the other ones, okay, I am going to use a Pythagorean identity to change this identity that I currently have existing. So I'm going to go ahead and I'll put a box around this saying, hey, this was good. Okay. I'll do the same with the red one up here. This was the result of sine 2 theta. So I'm going to take the expression that's in green and I'm going to change it. One thing that I'm going to do is I'm going to take cosine squared and use Pythagorean identity to replace cosine squared with 1 minus sine squared. So if I replace that with 1 minus sine squared, which is a Pythagorean identity, just kind of rewritten, okay? I get 1 minus sine squared replaces this minus the sine squared that was already there. When you put those two like terms together, I got a negative sine squared and another negative sine squared. That's going to be equal to 1 minus 2 sine squared x. Again, or theta if you're working with theta, okay? But that would be this guy right here, 1 minus 2 sine squared theta. So that's the second of my double, or cosine of a double angle identity. And let's find the third one. If I want to find the third one, I'd replace sine squared with its equivalent Pythagorean identity expression. So if I do that, we'll write that maybe over here, I'm going to have that first cosine squared x, and then I'm going to subtract, and I'll put it in parentheses because I'll subtract both these. Sine squared gets replaced with 1 minus cosine squared x. Okay? So again, that's a Pythagorean identity. I replaced this guy with this expression. Now, I put it in parentheses for a reason because I'm subtracting both of these terms. So I'm subtracting the 1. I'm also subtracting negative cosine squared x, which really means I'm going to be adding cosine squared x to the cosine squared x I already have here. And that's going to give me 2 cosines squared x values minus 1, which would be the third double angle identity for cosine. Okay, so there's all 3 of those for cosine. We have the one for sine already. Finally, we're going to do tangent. I'm going to use purple. So if I find the tangent double angle identity, I'm going to use I'm going to use the sum of a tangent identity from that previous lesson. We did sum and difference identities. So I'm going to treat this as being the tangent of x plus x, or theta plus theta. Okay, that's how I get to 2 theta or 2x. Well, the tangent sum identity goes like this. I take tangent of the first plus tangent of the second all over 1 minus, we use the opposite sign in the denominator, tangent of the first times tangent of the second. And if that's the case, if I were to clean this guy up, I have 2 of these tangent x's in the numerator. So my numerator is going to be 2 times the tangent of x, or theta if you kept it as theta, over 1 minus, well, tangent times tangent is tangent squared. So 1 minus the tangent squared of theta or x, whichever variable you're using. So 2 tan x over 1 minus tangent squared x, that'd be this guy right here. So I'm going to pause for a minute and move on to another clip to get to half angle identities. So these are the double angle identities for sine, cosine, and tangent.